Okay, so welcome. If you are interested, please take a seat in front. You can sit down if you want. So we will have now the presentation on the project entitled High V.LO City. It's also a European-funded project in the framework of the Fuel Cells and Hydrogen Joint Undertaking, a public-private partnership led by the industry. And this is a big demonstration project for hydrogen-powered fuel cell buses. So Paul, you have the floor.
Thank you. Thank you. So, a new presentation. Thanks for joining me at this time. If you're in the transportation business, this is the place to be, because I'm going to tell you the story of how public transportation, urban buses, can go from the present diesel standards to really zero emission options. So I don't know if you can imagine that one day we will have overcome the problem of pollution. Are we really in a position to imagine that? And this is an attempt, maybe not the first, but definitely not the last one, to show that it is technically possible and that we should all strive to this same goal, which in the end is indeed less noise, but above all, no CO2 and no emissions. So I'm going to tell you how this European project contributed, and all of the partners contributed in achieving that same goal. Our story starts, oddly enough, in California. So, by the way, my name is Paul Genet. I'm the coordinator of this program, and Flip Bamelis is here with me. So I didn't know if I could make it, so I'm happy to be here and to explain, as the coordinator of this project, what it's all about. So the story starts in 2005, where we were asked by a Californian operator to please provide them with a bus that would house a fuel cell. And to be honest with you, I had never heard about a fuel cell before in my life. So we said yes, and that's how we came to supply 5 of these buses with the UTC fuel cell, 120 kilowatt at the time, to California. And those buses have traveled over 1 million miles together, and we have then been successful in securing a new contract. In the meantime, 2005 is almost 10 years ago. We have been able to continue to supply urban buses with fuel cells. As you can see on the left-hand side above is the next generation that we have supplied to San Francisco, to Oakland, California, as well as to Connecticut on the East Coast in the US. And then, of course, we have built our own prototype on the right-hand side for Europe to show that, yes, we can do this, and we can also integrate the complete driveline as it is and make this program successful. We then engaged into a new project, which is a co-funded European project through the Joint Technological Initiative and through the Joint Undertaking in Brussels, for which is well known under the name High V.LO City, which tries to accelerate the process of introducing new technologies and introducing zero-emission buses into the markets, into European markets. We have this. We then continued with this bus to Oslo in Norway, followed by other buses. This one have been supplied to San Remo in Italy, and the central one to Aberdeen in Scotland. So other 5 will follow to Flanders and 2 to Cologne here in the country. The project, of course, is centralized to this delivery and the use of the buses into regular service. So we're not longer showcasing technology, we're actually using them with passengers in day-to-day service, not just for the duration of the project. They intend, all of the operators intend to continue to use the buses for their usual lifetime, which is between 12 and 15 full years. So all the partners, of course, going from the industrial partners, the fuel cell supplier, Ballard Power Systems, through Waterstofnet in Belgium, and a number of players, including, of course, the suppliers of the hydrogen. These are the objectives. One of them, of course, is to really show that the technology works by actually putting those vehicles in regular revenue service for a longer period of time. And we will find out a number of things, including the fuel consumption, because this bus is a hybrid bus. So in essence, it uses two things. One is the batteries, and the other one is the hydrogens to be converted into electricity to drive the electric motors. We have two Siemens electric motors on board with 75 kilowatt each, and of course the batteries. We will also show that we can, from this experience and the data that will be provided, all of the buses will have a data logger. We want to know exactly, when they were in service, how many hours, what the commercial speed was, how many stops and go, what the regular energy consumption was, and when they worked and when they didn't work. So all of that is logged on board, and of course through the system of key performance indicators, then gathered and disseminated later on. We also want to use this opportunity to really create centers of excellence, where a one-stop address where people can get information about hydrogen in general, but also and more specifically about the use of hydrogen in this application. We want, of course, to get to the point where we understand the TCO. How much does the fuel cost at the end of the day? How much will the maintenance cost? How much will the bus cost at the end of the day? So we really want to get to the point after this project to understand and know how far we are still away from, let's say, a standard diesel bus or a diesel hybrid bus today. In other words, how much did we ask the customer, the operator, to pay more? What's the premium that we have asked him to pay more to get rid of all of the emissions and lower the noise dramatically? The program as it is comprises 14 buses, 5 for Antwerp, already stated, San Remo and Aberdeen. Aberdeen will have an additional 6 after those, which totals then 10 buses for Scotland. We will have 3 hydrogen refueling stations also on the locations, and the total budget of the project is 31.5 million, with a EU contribution of 13.5 million. So quite a substantial project that is, of course, very much followed and viewed by European countries and basically all of the world. What I would like to state here without reading all of the numbers is that we have shown with this project, that the price of the bus, which needs to come down dramatically, is coming down. With volume and technology evolving, this is and will happen. We don't need thousands of buses to do that, but it is going in the right direction. We have also shown that the warranty, if you're a bus people, then a bus will typically operate 4,000 hours in a year, which is 16 and 18 hours a day, like a commercial speed of 12 kilometers per hour. It's a very difficult and awkward application is a bus. So we have provided 15,000 hours of warranty, and if I remind you, it started out with 4,000. The buses in the US have 4,000 hours of warranty. The ones that we are doing now have 15,000. So already now we can safely say that you will only have to replace the stack once in the lifetime of the bus, which I think is a major statement. Even a diesel engine after 100 years need to be overhauled at least once or replaced at least once, if not twice, in its economic life. Okay, so what's the status of the project? We have supplied a number of buses already to Sanremo, to Aberdeen we have supplied 4, and to Antwerp we're in the process of supplying the buses as we speak. So they will be delivered soon, and they will be in actual service soon. So if you want to follow us, I'm looking at Sabrine now on Twitter or on the website. Please do, so that you can keep track of how the buses are doing in the coming months. The station is for some part up and running, especially in Antwerp. What we're using there is waste hydrogen from an industrial plant and using it again through compression of the gas and putting it into the buses. This gives you an impression of where the components are located. So typically it's the components are located in the rear end, where you would usually find the diesel engine and the transmission, so not very different. And as much as possible on the roof of the bus, because it has to be something that carries people and not technology. Therefore, the floor should be low. It should allow for handicapped people. It should have enough seats. It should have air conditioning and everything on it, as if it were a normal bus, except that this bus does not produce pollutants and noise. You have a number of tanks on the roof, which is your hydrogen. Each tank is 200 liters, so about 8 tanks would give you 1,600 liters, which equals about 40 kilograms of hydrogen. That is enough to work through the day, because it's a hybrid bus, which means that the batteries will be doing the work as well as the fuel cell. On top you have, of course, the cooling here, the cooling of the fuel cell and the power electronics. The traction batteries are on top of the bus and they're cooling, and of course then the air conditioning. It's quite a complicated piece of equipment here. We will not know what we're talking about unless we find out what we're talking about, which is, what do we really save in terms of emissions? And to do that, we have asked TÜV to really measure the emissions per kilometer. And this is quite complicated as well, but we have done that according to an existing cycle, a duty cycle, which is commonly known in the industry as sort 1 and sort 2, which is an urban cycle or a suburban cycle. The result is this. If you compare sort 1, which is the urban cycle, you can see that normally this bus would have to use 56 liters per 100 kilometers of diesel fuel, so heavy duty. In the hydrogen case, the fuel cell case, it uses 9.62 kilogram of hydrogen. If you compare that in terms of the energy efficiency, you can see that hydrogen is about 50% more efficient than is diesel. On the sort 2, the ratio is less dramatic, but even so, it's still important. So here's what we have saved. We have saved on the bus 825 tons of CO2 per bus. So if you can imagine a 100 unit bus fleet, it's times 100 tons. It's 82,460 tons of CO2 that you will have saved at the end of the day. The same with NOx, of course, and with particulates. There's a number of issues, of course, call it barriers, but we shouldn't really call it barriers because once they are solved, there is no issue anymore. The cost of the bus is still very high. It needs to come down with volume and technology, and it will. The maintenance facilities need somewhat modified, but not dramatically. You know, it's a gas, it will go up very easily, except that you should, you know, it should open automatically, automatic ventilation and the like. The refueling infrastructure is still, it's getting to be to an acceptable point, which is less than 10 minutes to fill the bus, like for any diesel, a little bit more than any diesel bus. It could go faster still, but there's also a request to get not to go faster so that the bus can be fueled during the night. Those are the options that will become available. The other thing is the gross vehicle weight, of course, because of all the components, it's a pretty heavy piece of equipment, so the cost should and can get down as well. So I think I covered most of the issues. What we do lack at this point in time is regulation. You know, all we do have is the regulation from the natural gas, which is at 250 bars, but that's it. You know, that's where you have to go by. This bus was European certified. It's a European type certification, which means we have done an FMEA study to make sure that it meets all the regulatory or the safety issues that one can expect, which includes, of course, first off, the fact that no hydrogen should ever come into the passenger compartments, which I think is the most important aspect, because in any occasion, whether it be accident or otherwise, you know, it cannot be that hydrogen just can flow into the passenger compartment. It has an automatic fire extinguishing system, so if ever it happens that the bus catches fire, then automatically, you know, the system will be in operation. So those things, of course, have already been addressed. We are in the process also of addressing safety issues while the bus is, where can it be? On the street? Yes. During fueling? Yes. In the washing street? Yes. In the workshop? Yes. In other places where it needs to go for inspection or otherwise? Yes. So we are absolutely going at length to understand and mitigate possible safety issues. So I think that will complete my presentation. Thank you.
So thank you very much, Paul, and thank you for your enthusiasm, I will say. This is very important for the future of the bus industry, and the paper is open for discussion. Any question from the audience? Yes.
Yeah, thank you for your presentation. You mentioned that buses prices were still very high. Could you tell us what they are exactly and where you think they're going to be in a couple of years?
That's probably the most difficult question, not what they are, but where they're going to be in 2 or 3 or 5 years' time. Where they are is still about 5 times the price of a diesel bus. 4 to 5 times the price of a diesel bus. What I do, where do they go? I think they must go to maximum 1.5 to 2 times the price of a diesel bus. So this is about the ratio that we are looking for. When the volume is reasonably up, we're not saying thousands of units, we're saying hundreds of units. And of course the technology improving over time, the next generations to come, whether it be batteries or electric drives or fuel cell. So this is the core of the cost of the bus at this time.
And maybe if I may add, what is the most costly part of the bus?
The single most costly part is the fuel cell module at this time. So I'm now looking at my friends to...
And what about the storage of the hydrogen?
You know, everything is relative. Relative to the fuel cell stack, it is not that much, but it's in terms of bus costing, it is still an expensive part. It is. But let me tell you this: when you make a comparison, first off, do you want zero emissions? I don't think there are a lot of options available. You know, at one time in the near future, we will have to make sure that our center of the cities that we do love, are free of any pollution, whether it be cars and definitely public transportation. I cannot imagine all of those little cars being electric, the ones that you see here, and operate well, and then for those who take the bus, they would come with a polluting diesel engine. It's not even in the minds of people to even consider that. So there is no other way, there is no other option. Of course, the development goes in many directions. If there is a battery tomorrow that will do the job, which is 18 hours a day, which is stop and go traffic, which is air conditioning, which is door open, door close, all the time, then fine. I mean, that's what we've all been waiting for. But we don't see this to be realistic in the future. So something has to produce energy to help the battery to make it through the day. That is about the summary of how we see the future. And fuel cells are a perfect way of doing that.
Any other question in the audience? So here come the producer of the fuel cell.
Paul, you've deployed buses, fuel cell buses, both in Europe and in the United States. What kind of similarities do you see, or what kind of differences between your deployments here and your deployments in the States have you seen? Anything notable?
Not really on the application. I mean, an urban bus is an urban bus on both sides of the ocean, so it's heavy duty application. In terms of the bus, that's different. I mean, there is legislation in the US which does not apply in Europe, especially, that I forgot, is that you have seen on this one that there is a third axle. For the mere reason that in Europe the maximum weight is 18 tons. If with all of the components and all of the hybrids and all of the driveline weights, you're sitting there with 18 tons maximum load, your passenger capacity is reduced to, let's say, at best 65. And it's not a good commercial pitch to say that this bus costs you 4 to hopefully 2 times the price of a diesel bus, except that you can only carry 65 passengers instead of 100. So we will all have to do an effort on the weight of the components, but also the third axle is the real solution, whether it be articulated bus or 13-meter bus. That's the way it is, you know.
So yesterday you were also making a good comparison between a bus and a trolleybus. Can you emphasize a little bit the difference and how you want to compete between a trolley and a bus?
Yeah, let me first say that our company is not technologically linked, so I have no commercial interest to say one or the other, because we build trolley buses, lots of them, and we build fuel cell buses. So I believe that a trolley bus system is the one that we would recognize as being the most reliable presently available local zero emission public transportation system with the bus. There's no doubt about it. It's 100 years old. It has been used all over, and whether it be climates or applications or hills or whatever. So that is the most reliable bus system at this time. And the question comes, what are the alternatives as a zero emission option? And there aren't many, because trolley buses needs a system, needs wires, overhead wires, need underground stations, need maintenance, needs investments, huge investment. So, and is not flexible. You know, outside of the lines, you can do very little. You know, you could use your APU, which is an auxiliary power unit, mostly a diesel, which doesn't even comply with this current Euro standards. In other words, you see very modern trolley buses with a Euro 3 or a Euro 2 engine, which shouldn't be there in the first place. But that's the way it is. If you then want to improve your flexibility without having to have an APU in the first place, because you know you will drive a fuel cell bus anywhere, then I think the next in line in terms of promise, in terms of offering the features that you would want as an operator, I think the electric fuel cell bus is definitely the next in line. On the trolley bus systems, what you can see for those who have started new networks, which are only very few. In my mind, it is Avellino in Italy, it's Lecce in Italy. It is maybe going to be Leeds in the UK, after having made studies for the last 10 years. So most of them, most of the cities, most of the regions are just waiting on a better alternative in terms of not using so much money as an investment, not being subject to public works and construction works, and offering more flexibility. And then again, I will come with the fuel cell bus.
The last question in the audience.
Sorry, you mentioned about technology challenges for the buses. We know that for other constructors than Van Hool, there were a problem with DC-DCs. Could you tell us exactly where you see the technological challenge to be?
On the fuel cell bus or on the fuel cell bus? The fuel cell bus is going to be there for a long time. It's not like this is a hype. It's not like this is what politicians want, therefore it will appear left and right. It is, as far as we know, the solution to a local zero emission alternative in the city if you want it. What we do find is that the fuel cell power can probably be lowered. It will be smaller. It will be less expensive, and it will live longer. On the contrary, the batteries are probably going to be more powerful and provide more energy with the same size and weight, and therefore offer a good combination. I think the fuel cell bus will survive because of the battery technology, and the battery technology will need the fuel cell to jointly provide the traction on the bus. So it's not like a battery bus or an electric bus, or this is hype. This is the hype portion of it, because it is an electric bus. It's a full electric bus. It's always and always electric. In real life, the bus will start on the battery, the fuel cell will take over, the driver will brake, the braking energy is recycled into the battery and reused again to drive the vehicle. If the batteries are full, it's going to the brake resistor. If the brake resistor is full, it's going to dissipate into the air, but whatever is in the brake resistors is being used again to heat the bus. So it's the most energy efficient way of doing things.
And have you heard any problem with the DC-DC converter?
No.
So this is the last question. Thank you very much again, Paul.
You're welcome. Thank you.
And we will restart in 3 minutes from now.